Good day, ladies and gents. All right, so today we're continuing Unit 7, right triangles. So right now we're on special right triangles, very important, the 45, 45, 90, and 30, 60, 90. We talked about those. We're going to continue those today, and we're going to go to the bottom of page 3. All right, so we've been building up to this idea right here. So we're getting closer to what we're aiming for. So let's get this going. All right, now how do we handle this problem? Well, you just have to break it up into two different shapes. So we have this triangle and we have this triangle. So we want to focus on the one that has a side that is labeled. So which one has it? It's this one right here. So I'm just going to ignore this, pretend it doesn't exist. See, I'm just covering it up, and I'm just going to focus on this triangle right here. So to help us out with this, I'm just going to draw it over here. All right, where this is 30, this is X, and this is 12. And notice I did that in pen. I probably should have made that longer, but you know what the main idea is. All right, so if this is 30 and this is 90, then this should have to be 60. All right, so this is a 30, 60, 90. And for 30, 60, 90, we have to figure out how we're going to fold it out. So where the 30 and the 90 is, that's where the fold is. So here's the 30 and the 90, so the fold goes out like this. So that makes a 60, 60, 60 triangle. Hopefully your picture is much prettier than mine. All right, so now, okay, so, and page 1 should be out next to you the whole time to help you out with this. So we know the outside is 2x. Well, let's just follow the steps. Step 1, ignore your variables. So this black x we're just going to ignore, pretend it doesn't exist, because the black x may be different from our red x. So we know that the outside is 2x. This is not real, and only half of this is real, so that'd be x. And then the fold, so the leftover, be x radical something. And it's x radical 3 because it was an equilateral triangle originally with 3 equal sides. All right, so then step number 3, solve for x. Set the number equal to the label. So what side had a number on it? 12. So 12 is equal to, what did you label it as? 2x. Solve. So I would divide both sides by 2, just showing more work than I have to, and x is equal to 6. So it's a little bubble thought. All right, so everywhere that we see a red x, we're going to plug in 6. If I plug it in here, go right back to 12. If I plug it in here, this would be 6. If I plug it in here, this would be 6 radical 3. Okay, so we're doing the work over here. Now put it back into the picture. So that's what we need to do. So let's put it back in the picture. So this right here is 6. And this right here is 6 radical 3. Right there. And you might want to make that black. So let's do that. Let's make that black. 6 radical 3. Okay, awesome. All right, so now that we have one of those sides so far. Okay, now let's do it again. Now we're going to focus on this triangle. So cover this up, focus on this triangle. So I'm going to redraw the picture. But this is 45, this is 45, and this is 90. This is y. This is 6 radical 3, and this is z. I know that's kind of hard to figure out what that is, but if you had x and y, what would this possibly be? Z. So that's a z. And be careful. I like to put a little dash here so I don't think it's accidentally a 2. All right, so just follow the steps again. All right, so this is a 45, 45, 90. So we want to turn this so our elbows are on the table and our arms would be equal to each other, right? So if we turn our paper, we'll be safer. So step 1, ignore your variables. Step 2, label. So these both will be x. And the leftover side be x radical something. And in this case, it'd be x radical 2 because you had 2 equal sides. Awesome. All right, so step number 3. Step number 3 says set the number equal to the label. So what number side do we have 6 radical 3? So 6 radical 3 is equal to, what did you label it as? X. Please notice that this x over here and this x right here are totally different because they're completely different parts of the problem. They're totally different from each other. All right, so this goes with this problem right here. Okay, so then step number 4 says plug in So plug x into the other sides. So every time we see a red x, we're going to plug in 6 radical 3. This go right back. This would now turn into 6 radical 3. And this right here, okay, so here's a good one. So this would be 6 radical 3 is where the x is, and we still have that radical 2 attached to it. All right, we can multiply radicals by radicals and whole numbers by whole numbers. So radicals by radicals and whole numbers by whole numbers. And so that would be 6 radical, and what's radical 3 times radical 2? That'd be radical 6. And that's as pretty as it makes it. All right, so now take that and put it back into the original picture. Okay, so back in the original picture, this side right here was 6 radical 3. Got that? This side right here is 6 radical 3 as well. And this side right here, we said was 6 radical 6. All right, and your final step. Answer the question. This side was a black x. This side was also 6. This side was a black y. This is 6 radical 3. And this side was a black z. This was 6 radical 6. And those are your answers. Excellent. Okay, so now that's page 3. Okay, let's go ahead and jump to page 6. Let's jump to page 6. So you should have already done pages 4 and 5, and now we're going to do a couple problems from page 6. All right, so on page 6, we're going to just do this over again. We're just going to do the same thing all over again. So let's just do it. No, and please remember, I like to do the work off to the side, and then leave this as pretty as possible. Okay, so I think that you should go ahead and draw the 2 triangles separate from each other. So just focus on one triangle at a time. So which one has a number with its side? The top one right here. So this top one, okay, just making a smaller version of it. Okay, so this is 45. So this would have to be 45. That's 90. This is 14 radical 2. And this right here is x. Okay, and I'm going to zoom in just so you can see a little better. All right, hey, look, our elbows are already on the table. Isn't that nice? Step 1, ignore your variables. Step 2, label. So if our elbows are on the table, our arms are x, and our leftover side is x radical what? In this case, it's x radical 2 because they had 2 equal sides. Okay, step number 3, solve for x. So I'm just following these steps. So step number 3, solve for x. Set the number equal to the label. All right, set the number equal to the label. So what number did we have? 14 radical 2. And that's equal to, what did you label it as? X. Oh, cool. X is already solved for us. That's a little bubble thought. Okay, step number 4. Every time you saw a red X, you're going to plug in 14 radical 2. So this would be 14 radical 2. Awesome. This is already 14 radical 2. And this would be 14 radical 2 is what x is, and you still have a radical 2 attached to it. So all we did was replace whatever x was. And 14 we're stuck with. What's radical 2 times radical 2? Radical 4. What's radical 4? Oh, that is the number 2. And what's 14 times 2? 28. So this side is 28. All right, now let's take all that work and make it pretty into the original picture. All right, this side was already 14 radical 2. This side right here is 14 radical 2 as well. And this side right here is 28. Awesome. Okay, let's do this again. So we have to do this triangle. So I'm just separating it over here. I'm just making the smaller version of it. Okay, so this right here is 30. So and this is already 90, so what will be left over? 60 degrees. This is y, z, and we just found out that this is 28. So you can either make it red or black, it doesn't matter. Okay, now step number 1, ignore your variables. Step number 2, label. So this is 30, 60, 90, right? So we have to figure out where we fold. So are we going to fold this way? No, that's 60 and 60 make 120. No, let's see. How about up here? No, that make 120 again. This would make 60, but this would make 120. Oh, here we go. So this would make a straight line, and then this would be 60, and then the 60 would be thrown over here. That's what we want. All right, so now we're looking like that, and we know that the outside is 2x because we're going to fold it in half in a second. So the outside is 2x. So this would be 2x. That's not real. Only half of this is real. So if all of this is 2x, then this right here is just x. And then the fold would be x radical something. Our leftover would be x radical something. And this would be x radical 3 because it came from 3 equal sides. And that's at least how we remember it. All right, step number 3. Solve for x. Set the number, which is 28, equal to what you labeled as 2x. That's what we labeled as. Solve for x. So in this time, we didn't, we had to, it wasn't equal to x like it usually is. We had to solve for it. So divide by 2 on both sides, and x equals 14. All right, so that's a little bubble thought. So step number 4, plug in x. So every time we saw a red x, we're plugging in the number 14. So if we plug 14 here, it go right back into 28. This would turn into 14 here, and this would be 14 radical 3. Now take all that messy work and put it back into the picture. So this side right here would still be 28. This side right here, the z, would be 14 radical 3. And the y, that side right here, was 14. All right. Okay, your final step is to answer the questions, right? So this side was a black x. This side was also 14 radical 2. This side was a black y. This also equaled 14. This side was a black z. That would also equal 14 radical 3. And those are your answers. Okay, and that's it. So pretty simple. Just make sure that you just take your time, figure these out, and just keep giving it a try over and over again. If you need any help, let me know, and I'll help you out. Have a great and wonderful day.